If we had to evaluate my favorite supplements to support liver health, then TUDCA would definitely be part of that list. And the reason why I'm so pedantic and paranoid about maintaining optimal liver function is because the reality is the world that we live in today is toxic. The food that we consume, the air quality, the water quality, there are things in our environment that can cause liver toxicity. And so why should you even care about liver toxicity? Well, because if you have a sluggish liver or if your liver is damaged, then you are going to see a decrease in your day-to-day energy levels. You might experience more brain fog. You might experience problems with metabolizing hormones. And so what I want to do in today's video is outline why TUDCA, which is something I personally use between 500 to 1000 milligrams every single day, why this particular ingredient falls part of my protocol. So what I want to do is start out by outlining what is TUDCA. Well, TUDCA is a hydrophilic bile acid naturally produced in the liver. Now, as a supplement, it has been shown to have potential benefits for neurodegenerative diseases, liver protection, kidney protection, gallbladder protection, gut health, glucose metabolism, obesity, and also weight management, and many more. Now let's look at the history of TUDCA. TUDCA is not a new substance by any means. Its use actually goes back to traditional Chinese medicine where the bile of bears was and still is extracted as it has high amounts of TUDCA. Among the classic prescriptions of TCM, there are 396 kinds of prescriptions containing bear bile constitute. If you aren't familiar with these concepts, this will sound very strange to you, but in the point of TCM view, bear bile is a cold medicine and is bitter in flavor and cool in nature, and it supposedly enters meridian of liver, gallbladder, and heart, and is used to clear heat, relieve toxin, clear away liver fire, and stop endogenous wind. In recent decades, modern pharmacological studies also claimed that bear bile has a wide range of pharmacological actions, including hepatoprotection and antibacterial, antiviral, anti-inflammation, anti-gallstones, hyperlipidemic, and some other effects. Luckily for bears, TUDCA is no longer manufactured using bear bile. Instead, it is synthetically created. What about the mechanisms? How does TUDCA actually work in the human body to protect the liver? The primary treatment purpose of TUDCA is for cholestasis, gallstones, via improving bile flow from the liver. Bile flow is essential for both the digestion of fats and the removal of waste products such as bilirubin and excess cholesterol from the body. These waste products are excreted through bile into the intestines, where they are eventually eliminated in the stool. Additionally, bile aids in the absorption of fat-soluble vitamins A, D, E, and K, supporting overall health. TUDCA is also a potent inhibitor of cell death, apoptosis, in part by interfering with the upstream mitochondrial pathway of cell death, inhibiting oxygen radical production, reducing endoplasmic reticulum stress, and stabilizing the unfolded protein response. The endoplasmic reticulum helps cells function by folding proteins correctly, but stress can disrupt this, causing a buildup of misfolded proteins, known as endoplasmic reticulum stress. To fix this, cells activate the unfolded protein response, which reduces protein production, boosts protein repair, and clears damaged proteins. In cell models, TUDCA is shown to help protect against ER stress by supporting proper protein folding and clearing misfolded proteins, partly through activating protective pathways. It shows potential for treating diseases like diabetes and neurodegeneration that involve protein folding problems. So what is making TUDCA so popular? Number one, TUDCA has been popularized for its wide spectrum of health benefits in the health and wellness space and bodybuilding community in particular. Second, it is also primarily popular for protecting the liver from general liver stress, aiding in detoxification, and protecting from damaging compounds such as alcohol, drugs, steroids, etc. However, there is new research which I'll be talking about today which indicates that the benefits extend to more organs and systems such as the brain, kidneys, digestive system, eyes, insulin sensitivity, metabolism, pain and inflammation, hormonal health, and weight management.
Real quick, do you feel like your current supplement stack isn't quite cutting it? If so, then you might want to check out my brand new supplement, Catwa Pure. Catwa Pure is a remarkable, lesser known Amazonian herb that has been used for centuries to support energy, mood, and libido. Scan the QR code on your screen to discover how Catwa Pure can take your supplement game to that next level.
Let's get stuck into the liver studies. How does TUDCA actually help with lowering the liver enzymes? At this point, studies have been showing very promising results for liver enzymes. This study by Pan and colleagues aimed to evaluate the therapeutic efficacy of taurosodioxycholic acid compared to ursodioxycholic acid in treating liver cirrhosis in a double-blind randomized trial involving 23 patients in China. Participants received daily doses of 750 milligrams of either TUDCA or UDCA over 6 months, with clinical biochemical, histological, and ultrasonographic assessments conducted before and after treatment. Of the 18 patients included in the final analysis, both groups showed significant improvements in serum albumin levels as shown by the figure, while the TUDCA group demonstrated greater reductions in liver enzymes ALT, AST, ALP than the UDCA group, suggesting enhanced biochemical benefits. However, neither treatment significantly impacted serum markers of liver fibrosis, and only one patient in the TUDCA group exhibited histological improvement. Both treatments were well tolerated with no reported side effects, supporting their safety for 6 months of therapy. These findings suggest TUDCA may be more effective than UDCA in improving liver function in cirrhosis patients, though neither affects fibrosis markers.
Now, what about how TUDCA can specifically help with bile flow?
This rodent study investigated how TUDCA may help cholestasis. Cholestasis is a liver condition where bile flow is disrupted, leading to liver damage. This study explored how taurosodioxycholic acid helps reduce liver injury in cholestasis and compared it to another treatment, obeticholic acid. Using mouse models, researchers found that TUDCA effectively reduced liver damage by decreasing bile acid buildup and protecting liver cells. It activated 2 key protective pathways, FXR, which regulates bile acid balance, and NRF2, which shields cells from stress. TUDCA also prevented liver cell death by blocking harmful signals that trigger apoptosis, a programmed cell death process. Unlike OCA, TUDCA showed unique benefits even in mice lacking FXR, highlighting its multiple protective mechanisms. These findings suggest TUDCA could be a powerful treatment for cholestasis, addressing both bile flow issues and liver cell damage. Additionally, in another rodent study, TUDCA significantly increases bile flow in cystic fibrosis-related liver disease, acting independently of CFTR function, while also altering bile composition to improve liver health.
Now, what about in non-alcoholic fatty liver disease? Is there potential research behind it in this regard?
This recent study by Wang and colleagues explores the potential of TUDCA in treating non-alcoholic fatty liver disease in mice. It found that TUDCA can reduce obesity and fat buildup in the liver, improve gut health, and balance gut bacteria. Specifically, TUDCA boosts the levels of beneficial bacteria like Allobacillum and Bifidobacterium, which help protect the intestine. It also activates liver processes that convert cholesterol into bile acids and decreases the absorption of fatty acids, ultimately lowering liver fat accumulation. These findings suggest that TUDCA could be useful for managing NAFLD by improving both liver and gut function. Additionally, another study by Wang and colleagues in 2018 investigated the effects of TUDCA on non-alcoholic fatty liver disease in a mouse model. Mice were fed a high-fat diet for 16 weeks, and TUDCA was administered during the last 4 weeks. TUDCA treatment reduced liver fat buildup, inflammation, obesity, and insulin resistance while improving gut health. Specifically, TUDCA enhanced intestinal barrier function by increasing tight junction proteins, reduced gut inflammation, and decreased lipid transport from the intestine. Additionally, TUDCA altered the gut microbiota, making it more similar to that of healthy mice. These results suggest that TUDCA may help alleviate NAFLD by improving both liver function and gut health. However, more research in humans is needed for this.
Now let's have a look at some other older studies on TUDCA. What has it shown in the past and what has it demonstrated as far as its potential benefits?
Number 1 is increased insulin sensitivity. In a randomized controlled trial of 20 obese men and women with insulin resistance, TUDCA treatment, 1750 milligrams per day, for 4 weeks resulted in a 30% increase in insulin sensitivity in the liver and muscle. The specific cellular mechanisms responsible for the increased insulin sensitivity are unclear. It is also unknown whether TUDCA is protective in healthy adults without insulin resistance. Number 2 is decreased cholesterol. In a small dose-response study in 24 primary biliary cirrhosis patients, higher doses of TUDCA treatment, 1000 or 1500 mg day, for 6 months decreased both total and HDL cholesterol compared to baseline, while the low dose, 500 milligrams per day, showed no change. The changes in cholesterol levels may be explained by the improvement of cholestasis and also by a decrease in cholesterol absorption. Number 3 is decreased inflammation in mice. In a mouse model of neuroinflammation, TUDCA treatment reduced the production of nitrites by microglial cells and astrocytes by inhibiting the NF-κB pathway. A triple anti-inflammatory effect on glial cells was also observed. And lastly, asthma symptoms. TUDCA has shown promise in treating asthma. Studies in mice with asthma found that TUDCA reduces airway inflammation, mucus production, and sensitivity, key asthma symptoms. It also lowers the unfolded protein response, a stress reaction linked to asthma. Additionally, research in humans showed that genes related to ATF6A were more active in asthmatic airways, suggesting that targeting ATF6A with TUDCA could help treat asthma. So let's look at some new research in 2024 specifically linked to the microbiome. This is where it gets really interesting. In the past year, there has been several hundred studies on TUDCA, which has indicated that TUDCA has even more far-reaching benefits than previously thought. Let's take a look at the new research. It's important to note that there remains to be few studies on TUDCA in humans, and many studies use rodent models. However, it's interesting to see the broad-reaching effects of TUDCA. Luo and colleagues this year aimed to investigate the effect of TUDCA on ulcerative colitis. Ulcerative colitis is a chronic inflammatory condition affecting the colon and rectum. It causes symptoms like diarrhea, often with blood, abdominal pain, and fatigue resulting from an overactive immune response targeting the gut lining. In the study, the researchers found that TUDCA may help alleviate UC by improving the gut microbiome. This is shown by Table A, which shows TUDCA restored gut barrier function. As shown in Table E, in mouse models of colitis, TUDCA restored balance to gut bacteria, particularly increasing beneficial strains like Akkermansia. These changes correlated with reduced inflammation and improved gut barrier function, as TUDCA protected against damage to intestinal tight junction proteins. This mechanism supports the idea that TUDCA promotes intestinal health by enhancing the gut's structural integrity and reducing harmful microbial imbalances, offering potential as a therapeutic option for UC. This next study here, whilst this is not medical advice, is looking at how TUDCA can potentially be utilized in osteoporosis. Osteoporosis is a condition characterized by weakened bones and an increased risk of fractures. Research suggests that oxidative stress plays a key role in bone loss, and antioxidants may help mitigate its effects. TUDCA and selenium are potent antioxidants shown to support bone regeneration and repair. A recent study by Tao and Shen in 2024 investigated the combined effects of selenium and TUDCA on bone defects in osteoporotic states, particularly in cell cultures and a rat model of osteoporosis. The combination therapy reduced oxidative stress by lowering intracellular and mitochondrial reactive oxygen species and increasing antioxidative markers. Additionally, it upregulated SRT1, a protein involved in cellular stress resistance and bone metabolism. In rats with hormone deficiency-induced osteoporosis, the selenium and TUDCA combination enhanced bone regeneration at defect sites more effectively than either compound alone, using a collagen sponge as a scaffold for localized drug delivery. This is shown by the figure A. These findings suggest that selenium and TUDCA together may offer a promising therapeutic approach for improving bone repair and countering the effects of osteoporosis, though more research is needed. What about retinal disorders? What effects does TUDCA have in retinal disorders? TUDCA has also been recognized for its neuroprotective properties, particularly in the context of retinal disorders. A systematic review of 24 studies highlighted its potential in preserving retinal structure and function across various conditions, including retinitis pigmentosa, diabetic retinopathy, retinal ganglion cell injury, and retinal detachment. Both in vitro and in vivo experiments demonstrated that TUDCA effectively delays neuronal degeneration and apoptosis in the retina. Mechanistically, it achieves these effects by inhibiting cell death pathways, reducing inflammation, mitigating oxidative and endoplasmic reticulum stress, and lowering angiogenesis. While these findings reinforce TUDCA's promise as a therapeutic agent for retinal diseases, clinical trials are essential to confirm its efficacy and safety in humans. Now, what about as it pertains to health span and lifespan? What effects can TUDCA have as far as improving the overall health of our overall biology? TUDCA has also been shown to have anti-aging properties and outperform its analogs TUDCA and GUDCA in promoting both lifespan and health span. This recent study demonstrated that TUDCA extends lifespan in C. elegans, a microscopic roundworm widely used in research for studying aging and disease, by reducing mortality and decelerating aging processes, effects that TUDCA and GUDCA failed to replicate. In mice, TUDCA supplementation improved age-related health markers such as muscle strength, mobility, and senescence-related gene suppression. Mechanistically, TUDCA interacts with heat shock protein 90, a molecular chaperone crucial for protein folding and stability. This interaction enhances HSP90's refolding activity, alleviating endoplasmic reticulum stress and preserving protein homeostasis. These anti-aging effects position TUDCA as a promising therapeutic agent distinct from UDCA, which lacks comparable impact on aging and cellular stress pathways. Now, what about as it pertains to brain health, specifically Alzheimer's disease? Again, this is not medical advice, although this is preliminary research in rodent studies. This review published this year highlighted the therapeutic potential of TUDCA in Alzheimer's disease, demonstrating its ability to slow disease progression and mitigate cognitive impairments in animal models. In AD model mice, TUDCA treatment improves spatial learning, memory, and recognition abilities as assessed through behavioral tests such as the Morris-Water maze. These improvements were observed both in preventive interventions and after the onset of AD, suggesting TUDCA's effectiveness in different stages of the disease. As shown in the figure, TUDCA's benefits are hypothesized to be attributed to reducing amyloid B protein deposition, preventing tau hyperphosphorylation, regulating apoptosis, protecting neuronal synapses, reducing inflammation, and alleviating metabolic dysfunctions. However, more research is still needed to clarify this. This positions TUDCA as a potentially promising candidate for AD prevention and treatment, though further research is needed to fully elucidate its mechanisms and efficacy, and it is not an approved treatment. Now, as you guys know, I'm always on the lookout for things that might help us to increase testosterone, and from this study, potentially TUDCA can be a powerful supplement for dealing with the harmful effects of BPA. Now, this study investigated the differential impact of oxidative stress on endoplasmic reticulum stress in bisphenol A-induced cytotoxicity in human epidermal keratinocyte cells, and the role of NAC and TUDCA in mitigating damage. So the key findings include: number one, cytotoxicity mechanism. BPA exposure decreased cell viability through elevated oxidative and ER stress. These stresses are interlinked, with ER stress exacerbating oxidative damage. Number two, intervention with NAC, N-acetylcysteine, an antioxidant, reduced reactive oxygen species but only marginally restored cell viability. Number three, TUDCA's protective role. TUDCA, an ER stress inhibitor, significantly mitigated ER stress markers and restored mitochondrial function and cell viability. TUDCA also reduced oxidative stress downstream of ER stress, showing its dual action on oxidative and ER pathways. Number four, combination therapy insights. Although combining TUDCA with NAC further reduced ROS levels, no significant improvement in cell viability was observed compared to TUDCA alone. This reinforces the dominant role of ER stress in BPA-induced cytotoxicity. And number five, apoptotic signaling. TUDCA effectively inhibited apoptotic pathways activated by BPA, including reductions in cleaved caspase-3 and PARP levels. By contrast, NAC's impact on apoptosis was limited. So, does TUDCA need to be taken with or without food? Well, general recommendations are to take it alongside meals, since it can increase digestive capacity and also improve absorption of various fat-soluble nutrients. An additional benefit of taking it with food is that taking TUDCA on an empty stomach may lead to GI distress. In terms of side effects, well, if you start at a high dosage, it can lead to some nausea, diarrhea, GI distress, and also potentially skin rashes. But these effects are mild and tend to resolve with cessation of supplementation. Now, dosage ranges do vary. We can see 1,750 milligrams per day for 4 weeks, improved insulin sensitivity and fatty liver disease. That's quite a high dosage. 10 to 13 milligrams per day for 3 months improved liver regenesis rates and decreased ALT. 500 milligrams daily for 2 6-month periods separated by a 3-month washout period improved liver enzymes with no side effects. 15 to 20 milligrams per kilogram of body weight of TUDCA found to be the best for bile salt composition. Now, dosages are tended to be splitted across different dosages and different times throughout the day. In summary, we can see that TUDCA is a remarkably versatile and potent supplement primarily used for liver and digestive health. However, continuing research shows additional multifaceted benefits for kidney protection, gallbladder protection, gut health, glucose metabolism, obesity and weight management, and potentially neurological protection and recovery. So it's definitely worthwhile checking out TUDCA. Again, if you actually want to purchase a TUDCA supplement that I've personally used, you can see that linked in the video description down below with a discount code. Otherwise, guys, thank you so much for tuning in. I look forward to seeing you in the next video.